All right, chemistry people, we're going to take a quick look at a question from the 2011 AP Chemistry exam. Question number 3 here. We're going to skip to just a couple parts of it that relate to the electrochemistry section of that question. It starts out, hydrogen gas burns in air according to the equation below. Boom, a fuel cell is an electrochemical cell that converts the chemical energy stored in a fuel cell into electrical energy. A cell that uses hydrogen as a fuel can be constructed based on the following half reactions. Boom, we're given the 2 half reactions there and their respective reduction potentials. As we take a quick look here and think about what's going on in this reaction, our oxygen is going to be reduced and our hydrogen is going to be oxidized. And so we are going to need to flip the half reaction for hydrogen here so that we can get its oxidation potential. And so as we write the equation for the overall cell reaction, again, we're going to sort of keep this first reaction the same. So 2H2O plus O2 gas plus 4 electrons forms 4 hydroxide ions in solution. And the reduction potential there is going to be positive 0.40 volts. We're going to flip the second reaction there to indicate the oxidation that hydrogen undergoes to give us H2 plus 2 hydroxide ions producing water and the loss of those 2 electrons there. Again, since it's our oxidation half reaction, we're going to flip this to give us positive 0.83 volts. Before we sum the reactions together, we need to make sure that we are losing as many electrons as we are gaining. In this example, we need to multiply the oxidation half reaction by 2 to balance our charge. Once we do that, and we recombine the half reactions, we end up with 2 hydrogen plus 1 oxygen giving us 2 water. And so here is our equation for the overall cell reaction. Boom. I'm just going to paste in the information that we worked in the last part of this problem. If you take a look, all we have to do then is add our 2 potentials there from the half reactions to give us the standard potential for the cell, which will be positive 1.23 volts. Okay, part F of this question says, assume that 0.93 moles of hydrogen gas is consumed as the cell operates for 600 seconds. 2 parts here. It says calculate the number of moles of electrons that pass through the cell, and then 2, calculate the average current in amps that passes through the cell. Okay, so a couple of ways you can answer the first part here. If you take a quick look at the information that you worked on in the previous sections, you can just take a look at the oxidation half reaction where you've got hydrogen involved there, and recognize that for every 2 moles of hydrogen, you're going to lose 4 moles of electrons. So with that understanding, it's just a matter of taking the 0.93 moles of hydrogen and recognizing again from that reaction that for every 2 moles of hydrogen, you're going to get 4 moles of electrons. And so when you multiply this through, you're going to end up with 1.9 moles of electrons that were passed through the cell. And that's part 1. Okay, now part 2 is going to ask us to calculate the average current in amps that passes through the cell. For this part of the question, we're simply going to use the equation where I, or the current, equals the charge in coulombs over the time in seconds. Now, we know how many electrons we have, 1.9 moles of electrons, and we want to know what the charge of those 1.9 moles of electrons are. Well, to do that, so we can play it in here for Q, is just to take 1.9 moles of electrons and multiply that by Faraday's constant, or that 96,500 coulombs. And that will give us a charge of 1.8 times 10 to the 5 coulombs. And we can take that and plug that into our equation. And then we want to divide by our time in seconds. It's already conveniently given to us in seconds, so we should divide that by 600. Therefore, our current in amps is going to be 3.0 times 10 to the 2 amps. Done. And then the last part here, it's asking us to think about some other fuel cells that use butane gas rather than hydrogen gas. The overall reaction that occurs in a butane cell is provided to us here, and then it asks us what is one environmental advantage of using fuel cells that are based on hydrogen rather than on hydrocarbons such as butane. Well, let's take a quick look at the products in our fuel cell that uses hydrogen and the products in our fuel cell that uses butane. We just make water in the fuel cell using hydrogen, but in the fuel cell using butane, we're making not only water, but also carbon dioxide. Carbon dioxide is one of those gases that directly contribute to the global warming of our planet. And so, as we think about explaining what one environmental advantage of using fuel cells that are based on hydrogen rather than hydrocarbons such as butane would be, we would state that unlike butane, fuel cells based on hydrogen produce no carbon dioxide. Carbon dioxide is a leading contributor to global warming. Done.